Okay, so we are talking about DFA to regular expression. Regular expression. So, given a deterministic finite automata, we have seen how we can construct a regular expression. So, this is just to recap q1, q2, qn, and we have a sigma delta. Here q1 is the starting state. So, now just to recap, we have defined a RJK, which is nothing but set of all x string such that we start with qi with x, we will go to qj, and no and the intermediate state we visit all intermediate states are less than equal to k. Okay. This we have seen. Now, we have also proved this recurrence. K minus 1 union of R I k, k minus 1 R k k, k minus 1 star, then R k j, k minus 1. So, this recurrence we have seen, and this is true for all I and j 1 to n, and also for all k to n. Okay. So, this part we have seen, and from using this recurrence we have constructed the regular expression like this. R I j k is nothing but R I j k minus 1 plus R I k k minus 1 R k k k minus 1 star R k j k minus 1. So, this is the relationship. This is the regular expression for R I j k. Okay. And this is true for all I, j and k. And R I j 0 we defined as this is A 1 plus A 2 plus A p, where this delta of q I A I are going to q j. Okay. And it is plus epsilon with this, if these rules are there, if I is equal to j, and if no such A I exists, then it is empty. It will corresponding to the empty side. Okay, because this will corresponding to the language R I j 0, and R I j 0 is same as this in a union form. This part we have seen. Now, today we will take an example which will give us a regular expression from a given DFA. So, let us take an example to construct this. Now, once we have this, now for the given DFA, suppose this is our DFA q n sigma delta q 0 q 1 f. Now, f is the final state. Suppose f consists of say q j 1, q j 2 up to say q j m. There are m final states are there. Then basically the regular expression which is accepting this language of this DFA is nothing but R 1, because 1 is the starting state j 1 n plus r 1 j 2 n dot 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 r 1 j n m n sorry. So, this is the regular expression we are looking for, such that L of r is equal to L of m. The language accepting by this DFA is same as the language of this regular expression. So, we will take some example. So, we will keep this. Okay, suppose we have given this, so we will use this, let us write this here. We have given this DFA, this Q1, Q2 and Q3. We have 3 states and this is the starting state. So, we have with 0 we go here, with 1 we go here, and with 1 we go here, with 0 we go here, and with 0 or 1 both we come here, and these two are the final state of this DFA. So, this is the given DFA. Now, we want to construct a regular expression for this DFA. So, these two are final states. So, what is the regular expression? Regular expression is nothing but R 1 is the starting state, R 1 2 3, there are 3 states plus R 1 3 3. So, this is our, this we have to find out, this R we have to find out, okay, because F is, F consists of Q 2 Q 3. Okay, so, let us start computing this. So, we will use this formula to get the this, but for start with. So, like we will put a table over here for k is equal to 0, then for k is equal to 1 and then for k is equal to 2, and this is our Rij k. So, first we will compute R 1 1 k, then R 1 2 k, R 1 3 k, then R 2 1 k, R 2 2 k, R 2 3 k, then R 3 1 k, R 3 2 k, then R 3 3 k. So, we compute all these terms in terms of with the k value. Now, for k is equal to 0, this is R 1 1 k. So, just we can have here what is R. So, like R 1 1 0. So, R 1 1 0 means, so we are at Q 1, we will be at Q 1. Is there any self loop over here? So, there is no self loop. So, it will be just epsilon. So, this is just epsilon. Now, R 1 to k, R 1 to 0. So, R 1 to 0. So, from Q 1 to Q 2, is there any move? Yeah, we have a 0 arc. So, it is 0. So, this is 0. Similarly, this is 1, this is 0, this is epsilon, this is 1. Now, R 3 1 0, R 3 1 0. So, that means from Q 3 to Q 1, is there any move from Q 2 through Q 1? No. So, that means this will be empty. Then this is 0 plus 1 and this is epsilon. Okay. Now, we can find out the next k. For the finding the next k, what we need to do? Say for example, if we want to find R 1 1 1. So, to find R 1 1 1, this one, we need to use this formula, this recurrence. So, R 1 1 1 is nothing but R 1 1 0. So, we put k is equal to 1 over here, R 1 1 0 plus R 1 1 0, R 1 1 0 star, then we have R 1 1 0. So, if you use this value R 1 1 0 is epsilon, all are basically epsilon over here. So, epsilon plus epsilon, epsilon star, then epsilon. So, this will give us epsilon. So, this is epsilon. Okay. Similarly, if we have say R 1 2, R 1 2 1, this one R 1 2 1 is nothing but if you use this formula R 1 2 0 plus R 1 1 0, R 1 1 0, k is 1. So, R 1 1 0, then R 1 2 0. So, if you put this value, this is 0 plus epsilon, epsilon star, and R 1 to 0, R 1 to 0 is 0. So, this will give us a 0, because this is epsilon, this is 0. So, 0 plus 0 union 0. So, the 0 plus 0 is 0. We are using those rules. So, this is basically 0. Now, similarly, R 1 3 we can compute R 1 3 1, yeah, we can compute here. So, R 1 3 we can compute like this. So, R 1 3 0 plus, so k is 1. So, R 1 1 0, then k is 1, R 1 1 0 star, then R 1 3 0. So, if we put this value, we will be getting 1 plus 1. So, 1 plus epsilon, epsilon star 1, this is 1. So, this is 1. Similarly, we can continue this and we will be getting these values. So, 0, 0, 0, 0, 1 plus 0, 1. You can easily verify this 0 plus 1 epsilon. So, this part is done. Now, we will use we will do it for k is equal to 2. So, once we do it for k is equal to 2, we need to use the formula, recursion formula. So, for example, R 1 1 2. So, R 1 1 2 again we can have say yeah, R 1 1 2, just a minute. So, this is again epsilon, because this is again if we use the formula R 1 1 1 plus. So, this is I, this is j, this is k. So, R 1 1 1, then R 1 2 1, then R 2 2 star, sorry, R 2 2 1 star, then R 2 2 R 2 2 1. If we use this table R 1 1, this is epsilon plus R 1 2 1, R 1 2 1, it is 0, then R 2 2, R 2 2 is 0 plus 0. So, it is 0 0 star, then 0. So, this will give us 0 0 star. Okay. So, this is nothing but this table we can fill, this is 0 0 star. Similarly, here also we can compute 0 0 star, This we have to work out 0 star 1 0 0 0 star, then 0 0 star 0 star 1, then 0 plus 1 0 0 star 0, then 0 plus 1 0 0 star, the last one is epsilon plus 0 plus 1 0 star 1. Okay. So, this is the up to k is equal to 2. Now, what is our regular expression? For our regular expression we need k is equal to 3. So, for that we need to calculate this 3 for k is equal to 3. So, finally, so this is after completing all this, finally, our answer is for k is equal to 3, Lm equal to R 1 2 3 plus R 1 3 3. So, we need to find out these two. So, what is R 1 2 3? So, this we have to get. So, I can just use this. So, R 1 2 3. R 1 2 3 is nothing but if you use this formula. So, R 1 2 2 plus then k is equal to 3. So, R 1 3 2, we are just using this formula, then R k is equal to 3, R 3 3 2 star, then R k is equal to 3, j is equal to 2, R 3 2 2. Now, if we put the value over here, R 1 2 3 is this one, R 1 to 2 is this one like this. So, if you put the value over here, we are getting 0 0 0 star, then 1 3 2, 1 3 2 is this one, 0 star 1, and then R 3 3, R 3 3 2, this one, this big expression. So, this is nothing but epsilon plus 0 plus 1, then 0 star, then whole star, then R 3 2 2, R 3 2 2 is this one. It is in the bracket 0 plus 1 and then 0 0 star. So, if you simplify this, we will be getting like yeah, we can do little simplification, 0 0 0 star will be remain same, and then plus 0 star 1, then this epsilon this will come, then 0 plus 1 0 star star, and then 0 plus 1 0 0 star. Okay. Similarly, we can find out R 1 3. Similarly, we can find out R 1 3 3 using that formula. It is nothing but 0 star 1 plus 0 star 1 epsilon plus 0 plus 1 0 star 1 star, then into epsilon plus 0 plus 1 0 star 1. Okay. So, this plus this our Lm. Lm is R 1 2 3 plus R 1 3 3. So, this plus this our Lm. So, if you simplify these two, we will be getting 0 0 star 1 0 plus 1, then 0 star 1 star into epsilon plus 0 plus 1, then 0 0 star. Maybe you can simplify a little further. So, this is the final regular expression for this automata. So, from a given DFA we can use the recursive formula to get a regular expression. Now, we will take some simple example. This is I wanted to show you that if we have two state of acceptance, two acceptance states, then we have that R 1 3 and R 2 3. Now, if you have simple one like if you have this DFA Q 2. So, if we have a 0 we go here, if we have a 1 we remain here, and from if we have a 0 we go here, 1 we remain here. So, this is our starting state and we have one final state. Okay. Now, what is the language accepting this DFA? We know this language accepting this DFA is the ending with 0. So, if this is M, L of M is nothing but x 0, where x belongs to x is any string. So, this is any string ending with 0, that is the language, and this we can write in regular expression like this 0 plus 1 star 0. This is our R. Okay. But now, this R we need to get it using that the formula. So, I will just give you the outline. So, what is so if you use that, so this is all. So, basically R will be coming from R 1 2, then there are two state R 1 to 2. Okay. So, R 1 to 2, for getting R 1 to 2 what we need to get? We need to get all the R. So, this we have to achieve. So, this is our k is equal to 0, k is equal to 1, k is equal to 2. K is equal to 2 is the final one, and this is R 1 1 0, R 1 2 0, R 2 1 0, R 2 2 0. Now, what is R 1 1 0? R 1 1 0 is, so Q 1, so it is 1 plus epsilon, because from Q 1 we have to go to Q 1, we have a 1 move over here. So, 1 plus epsilon, and R 1 to 0, R 1 to 0 is just 0, and R 2 1 0, R 2 1 0 is 1, and R 2 2 0 is 0 plus epsilon. Okay. Now, this one we need to fill. So, to fill this one, we need to use the formula like R 1 R I j k is equal to R I j k minus 1 plus R I k k minus 1 R k k k minus 1 star R k j k minus 1. So, then what is R? So, you have to find R 1 1 1. So, R 1 1 1 is basically R 1 1 0 plus k is 1, R 1 1 0, R 1 1 0 star, then R 1 1 0. So, if we use this, so this is our 1 plus epsilon R 1 1 0, then 1 plus epsilon. So, R 1 k is equal to 0, I j is both 0. So, 1 plus epsilon star. So, 1 plus epsilon, 1 plus epsilon star, 1 plus epsilon. So, we can all simplify this. So, this is give you this will give us. So, 1 plus epsilon means 1 plus this one. So, we can have 1 plus this. So, 1 plus epsilon like this. So, we can simplify this and we can compute all the values over here, all the values over here, and once we have computed all the values. So, we do not need to compute all the values over here, we just need to compute r 1 to 2. So, r 1 to 2 is nothing but if we use the formula r 1 to 1 plus r 1 to 1, then r 2 to 1 star, then r 2 to 1. So, this we can use this table to get this value. So, I want you to do this as an exercise. Okay. So far what we have, so we know that given a DFA we can have a regular expression. And we know given a regular expression, given a regular expression, we can construct a epsilon NFA. And from this epsilon NFA, we can construct a NFA, or directly we can construct a DFA. This is subset construction. So, basically given a regular expression, we can have a DFA, given a DFA, we can have a regular expression. So, this we can write it here. So, this is DFA. So, from DFA, a regular expression, then NFA, and here we have epsilon NFA. So, from DFA we can have a regular expression, and from regular expression we can have a NFA, and from NFA we can have epsilon NFA, sorry, from regular we can have epsilon NFA, or from epsilon NFA we can directly have a DFA, and DFA can be treated as NFA and DFA can be treated as epsilon NFA, all these are true, and NFA is basically an epsilon NFA. So, this is the diagram. Okay. So, given a DFA we can have a regular expression, from the regular expression we can construct epsilon NFA, which is same as constructing the NFA, all these things. Oh, thank you.